Welcome back, everyone. In the last video, we learned about how to type values. In this video, we are going to start typing out this actual component where we're receiving these props. So one thing I want to talk about is typing objects as well as typing functions. Let's start with typing functions. When we think about this functional component, this is really, as we know, a function that has a specific return of some kind of HTML element. Other than that, nothing prevents it from being just a normal function. When you want to type a function, the way that you have to type the signature, so here, let's say we were typing some kind of function. We don't actually know what this function returns yet. This is just a placeholder for now. But as we know with typing, we use the colon, and then here we need to define the actual function itself. So if you think about the conditions of a function, important things of the function are the parameters that it receives and then the return value of the function. A function only cares about the types internally to itself when it receives properties. It has to receive the actual types that it's expecting to receive. So you want to type the parameters coming in. As far as TypeScript is concerned, whatever happens in the function is not TypeScript's business. But what comes out of that function as a return value, that is TypeScript's business, because TypeScript needs to ensure that whatever you're returning from the function matches the type that you tell is going to return. So the actual syntax of typing is going to be a curly bracket representing the parameters, and then a fat arrow followed by the actual return type. Now, let's say we have a function, and this function gets three values, A, B, and C. Similarly, what you're going to type is going to also be A, B, and C. But here what you're going to do is you are going to define the types themselves for these parameter values. So first, we actually need to match each variable in the parameter, A, B, and C. What you're then going to do is for these parameters, you're also going to use a colon. And this colon is going to say what these values are expected to be. So here, let's say for A, it's a string. Let's say for B, it's a number. And let's say for C, it's a Boolean value. What you need to return from this is now dependent on what the actual return of the function is. Let's say, for example, after all of these different calculations, what we return back is also a Boolean. Let's say it's true, for example. What you need to do here is that you need to return a Boolean. So you can just state that the value you can expect to come back from this function is going to be a Boolean. But we also have functions that don't have returns. Sometimes we just run a function and it doesn't actually return anything. If that's the case, then what we want to say is that we return back void. And with void, void is a special type that essentially says, hey, this is going to be nothing. It's very much like undefined in JavaScript. You just expect no return back, no specific type. And now with this, that's how you type a function. There are more complexities of typing functions that we will uncover as we go along, but this is pretty much the basics as far as we are concerned. So now the reason why we need to learn how to type a function is because we have these three types where the third one is a function because it's a handler. But what you'll also notice is that this is actually a destructure statement inside of our function. So what we're destructuring off is actually one variable called props. And props, as we know, is an object. So how do we type objects? Inside of TypeScript, you have two options for typing objects, and they're very unique. You actually have to define them ahead of time as either a type or as an interface. Now, types and interfaces are very similar. They used to be more different when TypeScript first came out, but over time, their overlap is significantly greater now. The key golden rule to remember about types versus interfaces is that interfaces are extendable, very similar to class components. If you remember with class components, you can extend one class component from another and inherit all of that class component's original methods. Similarly, with interfaces, you can actually do the same thing. So let's say we were to define an interface. First, you use the keyword interface, and then you have to write the name of this interface that you want to call it. So for us, if it was search box properties, then we would say I, because all interfaces start with an I to designate that they are a interface. I search box props. This is some kind of object. Then you put the curly braces, defining to this TypeScript file that this is now an interface. The inside is going to represent the shape of the actual object you're trying to define. So here, because we're looking at class name, placeholder, and onChange handler, we would say class name. Now, class name needs to point not to a value, but the actual type, which we know is a string. So that is going to be how you type these key value pairs inside of TypeScript with an interface. Similarly, we could say placeholder, which is also a string. Now, if this placeholder is an optional property, you can put a question mark here. This will now tell TypeScript that what you can get here is either string or null. It's essentially the equivalent. Because with an optional placeholder value, we're essentially declaring to TypeScript, hey, you can expect a string, but I might not always give it to you. Now, as for the actual onChange handler, the reason why I started this conversation about types and interfaces is because I was talking about how interfaces are extensible. So what I mean by this, okay, here we have our props. We've typed two of them. We haven't typed the onChange handler. We have this interface that defines the object shape and the corresponding values that we're expecting. If we do colon and then I search box props here, so we're saying that the props that you're going to receive is of this type of I search box props, you'll notice that we see onChange handler does not exist on our type. What we could do, of course, is simply just add it as the third parameter here inside of this interface. But when I say that you can extend, essentially you can do this actually a couple of ways. Let's say, for example, we had some random additional interface. Let's call it change handler. So I change handler props. And this takes some onChange handler as a prop. And what it receives is some actual function definition. So let's say it's A, which is a string, and then it returns back void. Let's use that as the example. What you can do is you can actually say interface I search box props extends I change handler. And now what you'll see happens is that this I search box props is now passing. Because what happens is that our I search box props is extending whatever was inside of here. So this is actually getting added into this I search box props as well. So we're inheriting whatever additional props were on this iChange handler props as far as typing is concerned. Another thing that you can do with interfaces is you can actually overload them. So if we write this twice, TypeScript under the hood is going to also combine these together so that your iSearch box props now contains all three of these values. This is designed pretty much mostly for object-oriented programming style inside of JavaScript. So most likely you're writing Node or you're writing some Angular code, which is also more object-oriented. But the main idea with TypeScript here is that it's giving you this ability to write interfaces that are extensible as well as composable through this overloading, which is where you're saying, hey, I'm going to define this more than one time. I just want you to combine all of them together into one final shape. This is interfaces. The alternative is to write types. Types are very similar to interfaces, but we lack both of these functionalities. We do not have the ability to overload, and we do not have the ability to extend. So we'll talk about types in the next video.